Hey everyone, good morning or afternoon or evening. Start by getting logged into Clever for me, please. So today I just want to ask what's filling your tank and what's draining it? What's making you feel good and energized and what's taking that away from you? Some people might be feeling that one of the things draining them were some of the events that happened on Wednesday in Washington, D.C. So I do want to just give you a space to air out how you're feeling or what you're thinking after that, because that could have been a draining experience. It also could be something that you didn't think about, and that's fine too. So, welcome to lesson 33 of week 17. This is our last new lesson with new content. So, it's super exciting. Today, we're talking about bonding to kind of wrap things up and get us ready for this final assignment that you're going to be doing next week as a potential grade booster and way to show me that you have mastered all of the concepts we've been covering. So, some announcements. Remember to check assignments for grades or for comments. I haven't done a lot of grading this week. I meant to yesterday, and then some things came up. But I will be getting to it in the next couple days and this weekend. Remember to do your ed puzzles, to watch those lessons all the way through, to watch to complete the lessons to your best of your ability, because that's where you get the information to be able to do the assignments. Remember to use your resources. Take advantage of the fact that you can use your assignments to help you complete other assignments. And remember our expectations. It is important that as we get ready to think about moving into the classroom, that we start to remember, what does it actually look like to be a student in an actual classroom? Let me tell you about makeup work. So I am continuing to accept makeup work through January 10th. So for the first 16 weeks, that's not stuff through this week, all of that needs to be in by January 10th. The work from this week, week 17, I will accept until next week. But I do need you guys to get that old makeup work. I need that to be in now, because I need to start grading that and getting that taken care of. Make sure that you're always watching those recorded lessons to go with assignments so that you can make sure you know what you're doing. If you're just going in blind trying to do the assignments, it's probably going to be really hard. But don't give up. If you're asking, how can I improve my grade or what can I do to pass? This is your first step. The second step to that is the mastery assignment that I will go into way more detail on next week. This is an all-encompassing assignment. It covers all of the skills and things that we've talked about in the last 12 weeks in this second unit. It is, if you complete it fully and up to my standards, this will bump your grade up one letter grade, no matter where you're at. You can have the lowest U, and if you do this, you have showed me that you have mastered most of the content that we've covered this semester. And so if you complete this, it will bump you up to passing. If you're on the verge of an A and haven't been able to get there, if you complete this assignment, it will move you up to an A, no questions asked, okay? Because completing this assignment will, again, show me that you have mastered everything we needed to cover for this unit, and that you are deserving of improving your grade. This is going to be, again, explained next week, and you'll be given time to work on it next week, and it will be due by January 17th, marking the end of the semester. So the big thing on the bottom there, don't give up, okay? It's not over yet. We can get your grade where you want it to be. I wanted to let you know about some other opportunities for some extra help. It's starting here at the end of the second semester, but is going to be continuing as we work through NTI for at least a little bit more before we go back to school. This is an opportunity for you to come in from 1 to 2 on Wednesdays and Fridays. You don't have class during that time, to get some individualized instruction from a teacher one-on-one. You can come to work on any content. You don't just need to come to work for my class. So if you're feeling good with my class, but you're struggling in English, come there, and there's some English teachers that can help you. Or yesterday, I helped somebody with math. I haven't worked on math in forever, but they came in and I was able to help them. So to get back to our topic, this is week 17, and we're talking about how atoms bond. This is our last new day of content. There are 2 assignments that we're going to talk about at the end of class, and that will kind of wrap things up for the week. Remember always that you need to be watching these lessons before you try and complete the assignments, or else it will be real mad tough. Thank you for showing up, and let's jump into today. So let's start. Open your periodic table. It is one of our last lessons with the Unit 2 periodicity. So please have that open. We will still need a periodic table for the next Unit 2, though. So let's start with this. Let's think about this. What do you see? Just what do you visualize happening in these two figures, figure one up here and figure two down here? What do you visualize happening? The second thing is that I want you to tell me what are some things that you can infer about these atoms, particularly if you want to think about their electronegativities. What are inferences that you can make based on what you see here? All right, so what you should say that you can, some things that you might say you see are atoms, okay, with these middle parts being the nuclei, these little white balls on the outside being the electrons. In this top figure, which is described as ionic, we see this element willing to give up an electron to this element over here. Versus down here in figure two, which is labeled as covalent, you see them passing their electrons back and forth and both getting to use them. And there's multiple electrons on the table that they're both using. All right, so this shows us the difference between ionic and covalent. Ionic, we have an electron being given. Over here, they're both using the electrons together. Some inferences that you might make is that this element must have a higher electronegativity if it's able to pull this electron away from the person or the element over here. And you might infer that these two have similar electronegativities because they're sharing the electronegativities between them. Now, to take that a step further and focusing just kind of on that last picture, focusing on this figure here for covalent, because these are both covalent bonds being represented. Again, tell me, what do you see happening in this picture? Just what do you notice is going on? And then what can you infer about these elements or the differences in particularly the electronegativities? So what we see represented here are the two types of covalent bonds that we have, nonpolar and polar. We're going to talk way more about those in another unit, but we should start to see some pretty clear differences right now off the bat. So in this over here, we see that they're being shared. They're being shared over here too, but in this nonpolar one, we see that they're both happy and equally pulling. Neither is providing more force than the other. Over on this side, the chlorine, though it is still being shared with the hydrogen, it's being pulled more towards the chlorine. The chlorine is stronger and pulling it more this way. So some inferences that you might have from this is that these two elements must have similar electronegativities. Neither one is more electronegative than the other, so those electrons are sitting in the middle. That makes sense because they're both hydrogen, so there's not really an electronegativity difference. With these over here, the chlorine must be a much more electronegative atom because it is pulling the electrons way more fiercely and forcefully towards itself away from that hydrogen, and that hydrogen is struggling. So this all has to do with electronegativity. And to remind you, electronegativity is the tendency of an atom to pull or attract electrons towards itself. How strong an atom is for electrons, how much muscle it has for those electrons. So with that reminder of the definition, taking a look at this chart where the literal electronegativity numbers are listed, as well as there's colors to help signify the strength. The more red it is, the more electronegative an atom is. Where on this chart or what types of elements have the highest electronegativities? So you should notice that the elements with the most red and orange are up here, and the biggest numbers are up here in the top right corner, which represent our nonmetals. All right, so if these nonmetals up here in this right corner have the biggest electronegativities, what does that mean they're going to want to do? Or what does that mean that these nonmetals how they're going to react in terms of their electrons? So what this tells us is that these nonmetals are going to be pulling electrons more towards themselves because of their big electronegativities. They're so strong that they're going to pull them towards themselves. Let's look at the flip side of this. Based on this chart, which elements have the lowest electronegativities? So the ones with the lightest yellow are over here in this first column, particularly in the bottom left, all right? But as you go across in general, we see that these metals over here are the things with the lowest electronegativities. So similar question to before, if those metals have the smallest electronegativities, what does that mean about metals and how they're going to, or what they're going to do with their electrons? What it means is that they're going to be more likely to give their electrons away to things over here in this right corner that have much bigger electronegativities. Right? The metals want to give them away. They want to get rid of them. And these nonmetals that are super strong are willing to take them. So all of this movement of electrons, of taking and accepting and receiving, is to the purpose of meeting the octet rule, which is that all elements are shooting for this stable, happy, full valence shell, which is 8 valence electrons unless we're talking about hydrogen or helium. So what's generally going to happen is that nonmetals are going to accept electrons and they're going to share them, or metals are just going to, whereas metals are going to be the ones that are giving them away. And so to figure this out, what we did on Tuesday is we looked at the electronegativity difference between different atoms. Okay, so let's do this practice together. If we look at strontium, which is Sr, and sulfur, which is S, what types of elements are they? Are they metal or nonmetal? And what are their electronegativities? So strontium is definitely a metal, and sulfur is over here. This is our cutoff line. Sulfur is definitely a nonmetal, and their electronegativities are as such. Sulfur has an electronegativity of 2.6. Strontium has an electronegativity of 0.9. So what is next? The next step is to figure out the difference between them. So the difference between these two elements is going to be 1.7. Now, looking at our chart, what type of bond does that mean is going to be formed? 1.7 is bigger than 1.5, and since we have a metal and a nonmetal, that acts as another piece of proof to tell us that this is going to be an ionic bond. It's going to be ionic. Ionic bonds occur when you have metals and nonmetals. Metals lose their electrons to the very accepting nonmetals, in showing a transfer of our electrons because their electronegativity difference is like huge. What forms then are things called ions. So if we go back and remember our ion and isotope time, we're talking about elements that have lost or gained electrons. That's literally what an ion is. And that's why ionic bonding is called ionic bonding. You're left with a negatively charged ion, which is called an anion, and a positively charged ion, which is called a cation. And here's a pretty nice visualization of this process. Again, the goal is for both of these elements to reach a full valence shell of 8, and that is what ends up happening. The sodium has a small electronegativity. The fluorine has a really big one. It pulls that electron all the way off of the sodium, resulting in that fluorine having a full valence shell. It forms a negative charge because it got a negative electron. The sodium, by losing its electron, gets a positive charge, and it is still left with a full valence shell because what's left behind, instead of having that one alone in its last shell, is now the outer shell is that second shell, which is already full, so it's meeting the octet rule. Now let's try this example. Let's compare chlorine, Cl, and bromine, Br. Are they metals or nonmetals, and what are their electronegativities? So we should notice really, really quickly that chlorine and bromine are both halogens, which are both nonmetals. Their electronegativities are chlorine has 3.0, bromine has 2.8. So what is the difference in these electronegativities? It is 0.2. 0.2 is less than our 1.5. It's actually down here in our first range, which represents nonpolar covalent bonds. So this representation of covalent bonding shows how electrons in the outer clouds or shells, or which we call valence electrons, end up getting shared between each atom to meet the octet. It's always going to be two nonmetals with similar electronegativities, and what's going to happen is instead of, again, the electrons being fully snatched away, they're both going to have access and use them. So here's a visualization of that one, of a covalent bond. Now, this is between two hydrogens. They're not shooting for 8. They're only shooting for 2 because they have one shell, and that one shell can only hold up to 2. But the idea is that we see them coming together, and then they both have access to each other's electrons. So both end up being happy with the 2 that they want. So the key takeaways here, ionic bonding has your metal giving away electrons to nonmetals, are trying to meet the octet. The electronegativity difference is not small. It's really, really big. And ions are formed because of those electrons literally being moved. Covalent has nonmetals sharing their electrons to meet the octet. And their electronegativity differences are not very big. It's not a big enough electronegativity that the nonmetal can pull the electron all the way to itself. There's two different types, polar and nonpolar, but we're not going to focus on that now. We'll circle back around to that in a future unit. So you have two assignments posted today, number 74, bonding simulation, as well as number 75. We're going to take a minute to look at those now. So bonding simulation, number 74. So what you'll see here at the top, there are some instructions. There is an example for you, and then there are 1, 2, 3, 4, 5, 6 that you have to do on your own. You're going to go to this link, which is right here. And what it will start you off with is choosing some specific elements. So back on the spreadsheet, I tell you specifically what combinations you should be making. So for example, we're making an Na and an O. All right, when you click on both of those, we see the information that pops up. We see that it identifies Na as a metal and O as a nonmetal. So that should be one clue for you right away that this is an ionic bond. The second thing is that it lists the electronegativity. So you can go and subtract 3.44 minus 0.93. When I do so, that equals 2.51. All right. So over here on your chart, you do not need to include any pictures, but you are going to have to fill in this set of information. So the electronegativity difference was 3.44 minus 0.93. Throw it in your calculator or round it. I don't care. But it is 2.5. That 2.5 is way bigger than 1.5. So this is definitely an ionic bond. The next piece is a little bit more tricky. So what you're going to want to do is pay attention to how many electrons each element needs to get or needs to lose. So this oxygen needs to get 2, but one sodium only has 1. What you do see, or what you can do though, is you can recognize that if you had 2 sodiums with 1, that would mean there's 2 electrons that could go over to complete this 6 on this oxygen. So if we try that out, let's use 2 sodiums and 1 oxygen. Complete my answer. It says it's correct. Now, if you don't get it right the first time, it's going to tell you, and you're going to click until you get it right. And what it's going to visualize at the end is this actual bonding happening. So we'll see that in this NaO, the 2 NAs have their 1 valence electrons. The oxygen has 2 open spots. Those 2 are going to go over to that oxygen to fill its octet and leave behind the sodium with its full octet in that unseen level underneath. And both of them are then going to have charge because electrons were literally moved. Again, you had to use 2 Na, so that means your formula is Na2 and 1 O with an O at the end. So again, writing all of this information, or all 4 of those pieces of information on each of the charts as you go through. Okay. The other assignment that you have assigned is a bonding Venn diagram where I have 9 different clues. You have to move each of the clues to a specific spot based on what spot or what that information should fit under, okay, to compare and contrast these 2 types of bonds. All right, so again, 2 assignments that are posted now for you, 74 and 75. I'm going to leave you with this. Please write for about a minute about the most important thing you learned from today's lesson. Awesome work, you all. So if you do not have any questions, you may get off here and keep working ahead. If you do, don't be afraid to reach out. Thank you guys so much and have a nice weekend. I'll see you later.